Hey everyone, what is happening? Well, we're on to chapter 5 now, and we're talking about acids and bases. So we've looked at compounds, and now what we're going to do is we're going to classify what type of compounds these actually are. And so some compounds can be acids or bases. Now we use these all the time in our everyday life. If you've had some orange juice or grapefruit juice, if you've had a pop lately, you've got carbonic acid in there. Or if you used vinegar, that's also an acid. Or you've taken vitamin C, and guess what? Every single person in our that is alive has stomach acid, and it helps break down food. Next over here we've got bases, and bases are things that like soap or shampoo, oven cleaner. They really break things down well. Local anesthetic called lidocaine, I had that on my teeth last week, and then also baking soda. So acids tend to taste sour, and bases feel slippery in your fingers, and they taste bitter. So this might be an example of this would be you're going to wash your mouth out with soap. You know, when you're a little kid and if you swore, you'd have to wash your mouth out with soap. So acids and bases can be extremely useful, but also they really need to be handled carefully. So some acids and bases are very corrosive, which means that they can burn your skin if you touch them or swallow them. And in the lab, remember, we never ever identify anything by tasting it or feeling it. All right. So with acids and bases, we use a scale called the pH scale. And we use a little p and a big H. And we can tell if something's more basic or acidic by using this. So substances with a pH of less than 7 are acidic. And substances with a pH of more than 7 are basic. Substances with an exact pH of 7 are said to be neutral. And now there's something I want to add to this. Well, I want you just to remember this. When we have something that's acidic, it's got more H plus ions. If it's more basic, it's got more OH negative ions. Now, if something's neutral, we can think about electrons here. Well, if something is neutral, that means the H plus ions are equal to the OH negative ions. So if we turn down, we have a little picture here, and we can see that we've got a few different things and the pH scale. So we've got pure water right in the middle, and we've got eggs, a little more basic. Milk, surprisingly, it's a little bit acidic. Tomatoes, bananas, grapes, lemons, all acidic. We've got baking soda, ammonia, soap, things like that are all basic. I'd like you to turn the page, please. So substances that are closer to 0 are more acidic, and substances that are closer to 14 are more basic. Sometimes you'll hear bases being referred to as alkaline. Now, what you'll think about this, I want you to think about Tums. Tums are basic, and what happens is if you've got too much stomach acid in your stomach, or there's unproportionate, you're going to take some Tums and you're going to change the pH in your stomach. So on a pH scale, this is really tricky. A change of 1 point means a 10 times change in the degree of acidity or basicity. So what that means is if we have a pH of 2 from a lemon and a grape that has a pH of 3, that means lemons are 10 times more acidic than grapes. And we're going to be touching on this in class as well. So a tomato has a pH of 4, and if we go back to lemons, they have a pH of 2, so that means lemons are 100 times more acidic. So every single time we go down one pH level, it's 10 times more acidic, meaning that it's got 10 times more H plus ions. And don't worry, we're going to be hitting that in class. So let's go on the other end now, and we've got oven cleaner has a pH of 13 and soap has a pH of 10. Well, that means that the oven cleaner is 1,000 times more basic than soap because it goes up 3 spots, and each one is 10 times 10 times 10. So we're going to be looking at that in class, and just a little preview, we're also going to be using some pH indicators, and we've done this with a demo. So this is how we determine pH. So a pH indicator is a chemical that changes color when an acid or a base is present. One example is litmus paper, and we're going to be using this in class. Now, this paper is soaked in a compound made from certain types of lichens. So these are the little things found on rocks. And litmus paper comes in two types. We've got red and blue. When blue litmus paper is placed in an acid, it turns red. When red litmus paper is placed in a base, it turns blue. So this is how I remember. I've got blue plus acid equals red. And we remember that with the acronym BAR. And then if we've got red plus base equals blue. And we get RBB. And we'll be testing this out and doing examples in class. So we've got these litmus papers. We've also got a universal indicator, and this is a mixture of different chemicals that change colors depending on what pH it is, and it could be a range of colors. So it could be red or purple. It could also be yellow or green. So pH can also be measured using a pH meter. So we've got some of these, and we're going to be using them as well. And it's a sensor that measures the actual ions in a solution. So we've got a couple indicators, and what you'll notice is you've got this in your data booklet. So we'll just flip over to your data booklet, and what we have is this in color. You're going to get this for the provincial exam, and what it shows us is that if we have one of these indicators on the left, like methyl orange, methyl red, and so on, and we have something that's basic or acidic, for example, for methyl orange, if it's got an acidity of 3 or less, it's going to be red. But if it's got 4 or more pH, then it's going to be yellow. So if you placed phenolphthalein in a solution of 7, so we've got our neutral right here, and if we look over at phenolphthalein, it would be colorless. Now, but if you place it in a solution at a pH of 13, so 7, 8, 9, 10, 11, 12, 13, so if we go right here and we look at phenolphthalein, it would be pink. Now, if you place methyl orange in a solution that has a pH of 3, methyl orange looks like pH of 3, so we got 7, 6, 5, 4, 3. Methyl orange, it would be red. But if you place the solution in a solution of a pH of 8, right here, it would be yellow. That's all we're going to do for this one. Have a good rest of the day.